Question 5. Sketch 2y is equal to 3 sine theta minus 1, and from your sketch estimate the smallest positive root. So I'm going to use Excel to do the sketch. I've got 2y is equal to 3 sine theta minus 1, so I can say that y is equal to 3 sine theta minus 1 divided by 2. That's the equation that I'm going to sketch. I'll have a cell called d theta, which is a small change in theta. I'm going to set that equal to pi divided by 10. Then I'm going to have a column for theta and a column for y. I'm going to start theta equal to minus 2 times d theta. So the graph starts just slightly on the left hand side of the origin. And then I'm going to say each value for theta is equal to the previous value plus d theta. And I'll put $1 in front of the 5 to make that a constant, and that's my theta. Now for y, I can say that that is equal to 3 times sine of the theta value, brackets, minus 1, brackets, divide by 2. Copy that down to this cell, and then copy these two down like so. Now if I block mark all of those and say insert graph scatter with smooth lines, there's a graph of 2y is equal to 3 sine theta minus 1. So let's put that in the title. That's a graph of 2y is equal to 3 sine theta minus 1. Now we're looking for the smallest positive root. So the smallest positive root is clearly here. So what we're going to do now is we're going to see on the graph here, that's minus 0.03 and that's plus 3. So the curve crosses the axis somewhere about here. So we're going to make a guess at 0.3 radians, and we'll copy this cell, Control C, and paste it here, Control V. So we can see it when at 0.3 radians we've got a negative value of minus 0.05, and at 0.35 what do we get? Okay, we've got a positive value, so we've crossed the x-axis between 0.3 radians and 0.35 radians. We want a value that's good to about 2 decimal places, I'd have thought. So let's try 0.34, and that gives us 3 zeros, so that's good enough. That means that 0.34 radians is quite close to 0, but it's good to 2 decimal places, which is what baseline works on. So let's put that into baseline. So theta is equal to 0.34. Are we right? Yes, we are. I'm going to leave question 6 to you because it's very similar to question 5. So let's now look at question 7. Sketch y equals tan theta, and from your sketch estimate the smallest positive value of theta when y is equal to 1. I'm going to adapt the graph from the previous question. So at the moment that is 3 sine theta and so on. So I'm going to say that this is equal to tan of B8, which is this theta value. And then I'm going to copy that down and down to there as well. And we'd better change that, I suppose, so that y is equal to tan theta. Tangent is sine over cosine, and every time cosine is 0, tangent goes to infinity. So we probably need to make our step value a bit smaller than we've got here. So let's have a look what happens when we divide by 20 instead of 10. Okay, let's try 30. Let's try 40. That's better. So we're now between asymptotes. So we're interested in the value when x equals 1, which is about here. So it's less than 0.8, so let's try 0.7. And the value is 0.84. Okay, it's close to 1, but it's not 1. So let's try 0.75. That's 0.93, so that's closer again. 0.79. Okay, that's pretty close. So 0.79 radians is where the line y equals 1 crosses the tangent. So let's put that into baseline. So we've got 0.79, and are we right? Yes, we are.